Okay, illustrative math, Algebra 2, Unit 3.6 is called Squares and Square Roots. So our goal today, I understand that the square root symbol means the positive square root, and I can explain why equations of the form x squared equal a can have two solutions, while equations in the form square root of x equals a cannot have more than one solution. All right, find the solutions of each equation mentally. All right, go ahead, pause the screen and take a look. And what you're going to do here is you're going to treat each side like they're two separate equations. You think of this as y equals 4, and this is y equals x squared. So as you look here, this here is the parabola. This is y equals x squared. And then all of these are each individual one. Y equals 4, y equals 2, y equals 0, y equals -1. So I look at this first one. When are they equal? So they would be equal when they share the same point. So here's my y squared equals 4. So my functions are equal right there at those points. So we want to know we don't really care about the y coordinate because we want to find x. You're going to get here x equals, if I look here, this is at -2, and this one's at 2. So -2 and 2. Or if you wanted to kind of make it a little bit easier, you could also write those as positive and -2 like that. Okay, either way is fine. All right, so when x squared equals 2, so again, remember, it's like you have two separate functions, y equals 2 and y equals x squared. So the x squared doesn't change, but the y equals 2 is now right here. So where are they equal? Well, they're equal right here where they intersect. Now, this one's a little tricky because they're not quite at a perfect number here, so you're going to have to kind of estimate it. So it looks like I have, let's see, this is -1. It's like -1.4, and then positive 1.4 roughly. And then let me move that up here. Whoops. So x squared equals 0. I'm going to go right here. And that is the only intersection. So the x coordinate is 0. And then x squared equals -1. Well, obviously, when I graph y equals -1 down here, that never intersects it. So this one would be a no solution. Okay, because clearly the line and the parabola don't touch. This is my minimum value right here at 0. So there you go. All right. Finding square roots. Claire was adding the square root of 4 and the square root of 9, and at first she wrote the square root of 4 plus square root of 9 equals 2 plus 3. But then she remembered that both 2 and -2 both square to make 4, and that 3 and -3 both square to make 9. She wrote down all the possible combinations. Then she wondered which of these are the same as square root of 4 plus square root of 9. All of them, only some, or just one? How would you answer Claire's question? Give reasons that support your answer. Well, you start taking a look at all of these, and if you start thinking about the graph, okay, so let's go back here. Here's my y equals x squared. So whoops. All right, so anyways, you think about your graph here, and it makes sense because, when you look here, x squared equals 4, you see that there's two solutions here. But I guess what I would say is, when you first learned about a square root, when I first learned, back in whatever grade it was when you learned the square root of 9, you didn't say it equals 3 and negative 3. Your teacher just told you that it equals 3. And the reason is because if a square root symbol is given to you, then it's denoting that they just want the positive root, okay? So the square root of 9 is equal to 3, and the square root of 4 is equal to 2, okay? Not negative 2. Now, if you had to insert a square root sign, okay, so like here, say this is the original problem. Okay, here's the original problem, square root of 9 equals what? And the answer is 3. If this is the problem, if I had to put the square root into it myself, if it's not part of the problem, that is when you need two answers. You need positive and negative. Same thing here. If it was x squared equals 4, when the square root is your idea because you need it to solve, that's when you need two answers, okay? But over here, if it was just, if it was more like this, the square root of 9 equals x, this is already in it. The square root's already in it. So your answer is just x equals 3. We don't need the negative. Same thing here. If it's square root of 4 equals x equals 2. Okay, so the real answer is here, just this one. Okay. Um, so how would you explain that? I would say if the square root is part of the original question or problem, you only want the positive root. Okay, no negative root there. Okay. All right. So here's the reason here. This is y equals the square root of x. And then this one here is really y equals positive and negative square root of x. So let's go back to, let's say square root of x equals let's say 4. Okay, so when I look at this graph here, if I were to graph, hold on. If I were to graph y equals 4, you would see that those intersect right there. Only one time, not twice, okay? So because remember, this is y equals 4, and this is square root of x equals y. So they only cross one time. That's why you only have one solution. Now, same thing here, if it's negative, it's still only going to have one solution, even if it's the same thing here. Square root of x equals 4. It's still going to be the same thing when I graph my line right here. We just have one solution. Okay. All right, the graph of b equals square root of a is shown. So think of, since a is on the x-axis, you think of a as x and b as y. Complete the table with the exact values and label the corresponding points on the graph with the exact values. Okay, so let's go ahead and let's do that. So remember, it's b equals the square root of a. So if a is 1, square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 12. It's going to be between 3 and 4 because the square root of 16 is 4. I'm going to type it into my calculator to get an exact value. Square root of 12 is 3.46. Square root of 20 is 4.47. So plot your points. So 1, 1. 2 is at 4. I'm sorry, 4 is at 2, said that backwards. 9 is at 3. 12 is at 3.46. 16 is up here at 4, if you look there. And then 20 is at 4.47. So there you go. Complete the table and label the corresponding points. Label the point on the graph that shows the square root of a equals 4. So square root of a equals 4. That would be this point right here. Because if you look here at this point, oh wait, no, wrong one. That would be actually, sorry, I moved that point on accident. That'd be right here because that's at 4. So you can see that the a would be 16. Okay, so let me move that one. That would be right there. Label the point on the graph that shows the solution to the square root of a equals 5. Well, 5 is up here. Looks like it's right there at 25. So right here, this would be square root of a equals 5. So the y coordinate is 5. A would be 25, obviously. It'd be kind of like saying here, a is 25. We got to 5. So label the point on the graph that shows the solution to the square root of a equals the square root of 5. So square root of 5 is going to be between 2 and 3. So square root of 5 would be, here's 1, here's 2. This would be somewhere right around here. I should have made this graph a little bit bigger here. Square root of a equals 5. There we go. Or equals the square root of 5, not 5, sorry. Okay, because remember, square root of 5 is approximately 2 point, I don't know what it is here off the top of my head. Square root of 5 is 2.23. So right about there. Okay. All right, here's the graph. The graph of t equals s squared is shown. So if you look here, this is my s axis, this is my t. Label the points on the graph that show s squared equals 25. So s squared equals 25. So 25 is up here. So here's my 25. So that would be any point that's right there. So that would be right there for those two. Label points on the graph that show the square root of t equals 5. So the square root of t equals 5. So like if I were to go back to this, wait, hold on here. If I go back here, if I have t equals s squared, if I plug the 5 in for s, let's do that. Plug in the 5 for s and I square root both sides. Now I can get to the square root of t equals 5. So originally you had t equals 5 squared. So think of s as 5. So here's my 5. It's actually the same point here. Okay, same point. So this is square root of t equals 5. Label the points on the graph that show the solution to s squared equals 5. So s squared equals 5. So s squared equals 5. So if I square root both sides, I get s equals the square root of 5, which we said was 2.23. So it's going to be like right up there with a height of 5. So right there, that would be oh wait, hold on. Yeah, that would be right. Yeah, because your s is equal to square root of 5. So s squared equals 5. There we go. All right, then this would be also here. All right, so what do you know about the number square root of 17? I would say there's only one value. It's approximately 4 point something because the square root of 16 equals 4, square root of 25 equals 5. It's between those two. It's 4 point something. There's no negative one. It's only the positive. The square root of 17 is, hang on, 4.12 approximately. Obviously, this is rounded. What are all the numbers that square to make 17? In other words, what are the square roots of 17? So, square root of 17 squared equals 17, and negative square root of 17 squared will equal 17. So your answer is negative radical 17 and radical 17. You got two answers there. Let's say a is a positive number. What do you know about the number square root of a? I would say there is only one value, not two. What are all the numbers that square to make a? So you got the square root of a squared. The square root and the square cancel out. And then you have negative square root of a. And if you square that, put the parentheses there, that will also equal, equal a. Now, how does that work? The negative squared becomes positive, and then the square root gets rid of the square. So the answer is, I'll just write it as plus or minus radical a. Is it possible for the square root of a to be equal to negative 10? Explain your reasoning. Well, is it possible? Now, if you squared it, you could plug in. If square root of a was negative 10 here, you could plug in a negative, square it, it would work. But here's the thing: if you take a square root of a equal to negative, if I take the square root of a number, it's always going to be positive. You can't, if the square root's already given to you, it has to be positive. So my answer here would be no. The square root is given to us. So it is indicating the positive root, no negative if it's given to you. Okay. All right, so the goal here, I understand that the square root symbol means the positive square root. Okay, so if I say, what's the square root of 100? Your answer is 10. Okay, now if I said x squared equals 1,000, and you have to put your own square root into the problem, then your answer is, well, I shouldn't have used 1,000. I should have used 100. Square root of 100, then you have to say plus or minus 10. Okay. Reason being, because if this was the original equation, if I plug the 10 in and square it, I get 100. If I plug negative 10 in with parentheses and square it, I also get 100. They check out. Okay. But if the square root's already given to us, just the positive. All right, find the solutions to the equations here. Square root both sides. Square root of 7 is going to be between 2 and 3. 2.65. Now we need the positive and the negative. So you're going to have two answers here. And again, think back about that. X squared is a parabola. Y equals 7 is a horizontal line. So kind of figure out there that they intersect at two spots. The only place they wouldn't would be at the vertex, or if they never intersect. The next one, that's supposed to be a square root of y. So this time, square both sides. Y equals 49. Now I don't need a plus or minus because the square root was already there. And again, think about that. Square root graph looks like that. And there's my y equals 7. Square root of, I guess I used x and y. I guess they're backwards, but if I were to use x and y axis, that's what it would look like. All right, how would you explain why the equation square root of z equals -7 does not have a solution? So I would say the square root is given to us problem, so it is indicating the positive root. So -7 is not positive, so it cannot be the solution. Okay. All right. So, oh, I already did that. I double put that slide on there twice, I guess. So, all right. Well, I hope you enjoyed this lesson. Thanks for watching.